Okay, guys, so let's start. So good afternoon, everybody. So as I told you, we're gonna have a lecture in the beginning, and then we are gonna have a test for 1 hour and a half. So I'm gonna finish 10 to 7. Okay, I'm gonna give you rest for 10, 15 minutes, and we're gonna start the test at 7. Okay. So let me continue what I explained last time. What I explained last time, as you know, I told you we have a number of ports. Okay. Any input-output devices has to be connected to one of the ports here. That's what I said last time. Also, very important. If you want to use a port, you have to configure. You have to write a command to configure this port input or output. Okay. Otherwise, if you don't do that, it's not gonna work. Why it's not gonna work? Because I give you more details last time. I told you when you do this configuration, actually you are gonna connect the circuit this way. If it is input, so this is what actually the configuration is gonna do in the hardware. So when you do the configuration, you are gonna connect the hardware this way for input. For output, you are gonna connect the hardware this way. This is what when you write one command to do configuration. Okay. That's why if you forget to do configuration, it's not gonna work because the circuit is not input or output. You got what I'm saying? So you have very clear. Any port you are gonna use, you have to configure it input or output. Okay. So that's what I explained. I also explained last time how can you configure these ports. Also, I explained data. So I explained two types of registers. One is called data direction register. Okay. DDR, and this is the register you have to use to configure ports input or output. Okay. Also, I explained we have what we call data register, and this is where you can get the data. If you want to get the data, you can get it from here, or this is where if I want to write some value on the port, this is where I have to write. Okay. Anyway, also last time I started to explain how can we make flashing LED. So this is what I explained last time, and this is the way we did it here. So here, as I told you last time, in the very beginning here, we have configuration. You have to do this configuration, as I said, okay? And then after you do the configuration, as I said last time, be set, okay? So this is what you are gonna do here, port B, okay? So you are gonna tell this pin is gonna be high. So PB0 should equal to 1. So so pin number 0 on port B should be high, 5 volt. Okay, this pin should be connected to an LED. So by doing that, you actually turn the LED on. Okay, so here you turn the LED on, and then using these two instructions, you're gonna wait 1 second. I'm gonna wait 1 second because I wanna keep the LED on for 1 second because I wanna do flashing. So I have to be on for 1 second, off for 1 second, on for 1 second. So after I turn it on, so I'm gonna keep it on for 1 second, and then I'm gonna write here instruction, bit clear. So what this instruction is gonna do is gonna put 0, BB0 should equal logic 0 or 0 volt. Okay. So actually this instruction is gonna turn the LED off. And then you are gonna wait 1 second, and then you are gonna go back to repeat again. Very easy, right? So turn on, wait 1 second, turn off, wait 1 second, repeat again. Okay, that's how we can make flashing. Okay, so that's what I explained last time. Now I wanna elaborate more. So let me delete this one. Let me quickly explain the configuration I explained last time, quickly. Okay, so here, because we are using port B, we are using PB0. So you have to configure PB0, you have to configure this pin. Okay, Here, yeah, that's what I'm using here. So what I'm using here, only one pin. So here, I have to configure this pin output, and that's exactly what I did here. So this one here, you configure PB0 as output. Yes. Before you use it, that's why this initialization has to be in the very beginning of the program. If you do it late, it's not going to help, right? So before I start to write the board, I have to configure it first, right? Same thing, before I read the board, I should configure it first. That's why this configuration should be done at the very beginning of your program, right? So this is number one. Number two, because as I said last time, when you use LEDs, you also use BG1. You remember BG1? This one should be as enabled. So you have to configure this one as output. Okay, that's what I did here. So this one, I'm gonna configure BG1 as output using bit clear. Is that okay? One more thing, as I said last time, the 4-7 segment and the LEDs are connected to port B. Okay, so all of them are connected to port B. That's why I said last time, usually you have to enable only one of them and you have to disable everyone else. At the time, okay, you are gonna only enable one of them, okay? Otherwise, if you don't do that, you're gonna see a number on the LEDs and then you're gonna see a random shape here, random shape. Doesn't make sense. You're not gonna burn out the board, but just doesn't make sense because you will see some random shape here. So the way you are going to do it is, if you want to use the LEDs, you have to disable the 7 segment. If you want to use the 7 segment, you have to disable LEDs. I have to use one at a time. Okay. So how can we do that? As I told you last time, every 7 segment it has one pin, exactly like this one, like BG. Okay, it has one pin to enable or disable, but this pin is actually PB0, PB1, PB2, PB3. So this is on port P, okay? And that's exactly what I did here in this configuration. Sorry, I think I made a mistake. Yeah, this is for the direction. I made a mistake, okay? So this is for configuration, port J as output by, I'm gonna configure it output by writing 1. That's what I told last time. When you write 1, you configure it output, okay? And then here, this one here I configure port P as output. What I did here, I configure the whole board as output. That's okay. I actually only 4 bits. So only I need 4. But here what I did, just I configure everything. That's okay because I'm not going to use the other 4. Okay. But for sure, you shouldn't do that. If you have, for example, if you have 4 input and 4 outputs, I have to use something else. But you know, what I did here, I configure that 8 pins as output. Okay. But actually, I'm going to use only 4. Okay. So it's not going to hurt. Anyway. So this 3 instruction should be used to configure ports. The ports I'm going to use here as output. All of them are output. I'm not going to use input here. Is that okay? Okay. You have to do that before using import. You have to do that. Okay. One time should be enough. Okay. One more thing. Now, as I told you, I have to enable the LED. So I have to write here 0. I have to disable the 7 segment. So that means PB0 to PB3. I have to put 1, 1, 1, 1. Okay, for once to disable them. That's what I did here. So if you look here, this is here. I'm gonna enable the LEDs by writing 0. Okay, here I'm gonna write 1. You can see here, guys. So I'm gonna write here in the PP0 to PP3. I'm gonna write 1, 1, 1. That's why you can see F here. Okay. By doing that, I'm gonna disable the 7 segment. Anyway, this is a configuration. That's what I explained last time. Okay. Now, I told you last time this should make a delay for 1 second. So now I'm gonna give you more details how this can make a delay for 1 second. Okay. So actually, as you see here, we have a function or subroutine. This subroutine is called delay y millisecond. So this function should make a delay, or should create a delay. This delay is actually, the value of this delay is y millisecond. What is y? Just a y. Okay. That means if I want to make 5 millisecond delay, so I have to put 5 in register Y before I put this function, and then I'm going to put this function. So this function is going to make delay with Y millisecond. Is that okay? Here, because I want to make the delay for 1 second, here I put 1 second Y, and then I put this function. This function is going to make 1,000 millisecond, which is 1 second. Right? So it's going to make 1 second delay. Okay. So if you need more or less delay, you can simply change it here. So for example, here you can make it, if I make it 500, and that's what I'm going to show a video now. So I'm going to, in this video, okay, I'm going to just play in this number. It's very easy, right? So if I can play in this number, if I can change this number to 500, that means I'm going to make it delay half a second and half a second. So it's going to be fletching, it's going to be fast. Half a second, half a second. You can make it 250, so quarter a second. Very easy, right? 250. So flashing is going to be faster because quarter a second, flashing is going to be faster. Okay? And in the video as well, I'm going to make the delay very short. So I'm just playing. I'm just changing the number and see what's going to happen. So I'm going to make here the delay 1 second. Oh, sorry, 1 and 1. So I'm going to make the delay 1 millisecond and 1 millisecond. I'm not sure what's going to happen. You will see in the video. You got what I'm saying? I'm not sure if you can see your eyes. Maybe you have super eyes. I don't know. So yeah, so I'm not sure if our eyes can see the LED turning on and off 1 millisecond. Okay, this is a very short time. I don't know what's going to happen. You'll see in the video. Okay, but again, what I want to tell you guys is all the programs in chapter 3, 4, 5, all the programs, I tested them. I'm quite sure they are working. I posted this program on the course website. Okay, and here in every slide, you can see the name. In every slide, you can see the name of the file. You can find it on the course website. So you can download. You already have the board. You can download all these files and you can run them. Okay, and you can play as I did. You can just change the number and see how the LED is behaving. Okay, so I'm going to show you here in the course website, as I told you. Yeah, here, chapter 3C and the assembly programs are here. So if you download it, as I'm gonna download now, okay. Yeah, this one. Okay. You have to unzip it and you have to use the password we use to unzip it. So let me put it here because I need them later. Okay, so let me now unzip it. Okay, so you find the programs are here. Every program, I'm going to teach in the slides, you can find it here. Yeah, so all the programs, you can see them here. You can just run them and you can play with them. Is that okay? Any question for C and for assembly? Okay. Any question? Okay, what I'm going to teach now, I'm going to teach this function. How this function is going to work? This is a function. This function has to make Y millisecond delay. This function is going to make Y millisecond delay. How this function works? I'm going to tell you how it works. So if you see here, guys, I'm going to show the main idea. The main idea is, as you know, as I said before, the clock is 24 megahertz. So every cycle of the clock, as I said before, should be 1/24 microsecond. Is that okay? Look at the idea. Look how we're going to make Y millisecond delay. What is the idea? The idea is, if you see here, guys, I'm gonna use instruction. This instruction are doing nothing. Just I want to waste time. Just I want to create a delay. So if you look this instruction, guys, push A, pull A. I'm doing nothing. Push ball, push ball, push ball, push ball. I'm not doing anything. Okay. So as programming or as functionalities, they are not doing anything. But if you count how many cycles, we're gonna have here to execute this instruction, you will find we need 24 cycles. If you add 2 plus 3 plus 2, so from here to here is going to be 24 cycles. Okay, so if you multiply 24 cycle times 1 over 24 microsecond for each cycle, that means this part is going to create 1 microsecond. So to execute this instruction, I need 1 microsecond. Is that okay? So to execute here, this one goes away from here. So I need this part is going to take 1 microsecond because this part needs 24 cycles, and as I said before, every cycle is 1 over 24 microseconds. Is that okay? Okay. Okay. So this part here is going to create, is going to make 1 microsecond. Okay, guys. Now, if I repeat this part 1,000 times, by this way, I can make what? 1 millisecond, right? Is that right? So this instruction here are 1 microsecond. I'm gonna do 1,000 times to make 1 millisecond. Very interesting. Why it is very interesting? Very interesting. Look how 1 millisecond is a huge time, is a big time for microcontroller. Okay, why? Just to waste 1 millisecond. Imagine, okay, imagine to waste 1 millisecond. I have to execute this instruction 1,000 times. I have to execute just only one millisecond. Is that okay? So that's true. Computers are very fast. Okay, and again, keep in mind this clock is too slow for sure. If you compare this clock with your laptop, okay, but anyway, so one millisecond is a long time. Anyway, so now here, now I created 1 millisecond. Okay, so from here to here, by repeating this part 1,000 times, I can make 1 millisecond delay. Is that okay? Again, don't forget, this function has to make y millisecond delays. Y millisecond. This part is going to make 1 millisecond. This part. In order to make y millisecond, so I'm going to repeat this part y times. I'm going to repeat this part. That's exactly what I did. So if you look here, guys, let me delete everything. Here, can you see this loop? So I'm going to keep looping. So every time from here to here should take 1 millisecond. Okay. So if I repeat this part, y millisecond. That's exactly what's happening. If I repeat it y millisecond, by this way I can make y millisecond delay. Sorry, if I repeat this part y times, I can create y millisecond delay. Is that clear? Any idea? Any question? Okay. Very easy, right? Very interesting. We just do nothing just to create a delay. Later, yeah, this kind of delays, maybe they have some problems. Later, I'm going to explain better ways to do delays, but still somehow it is useful. Honestly, if I want to make a delay 1 second, I don't think it's a good idea. 1 second is a huge time, right? If I want to make, for example, 20 nanosecond, 40 nanosecond, it would be okay, or even 1 microsecond. You can say 1 microsecond is okay, but 1 second is a huge time. So later I'm going to explain another way. But this also, still is useful, but again, I think it's really useful in case of small delays. Anyway, later I'm going to explain another way. But for now, any question? Okay, guys, you got the idea how it works? Okay. I want to tell you something important, guys, here as well, is actually here you are gonna get you are not gonna get very accurate delay. The delay is not gonna be very accurate. Why is the delay is not very accurate? Because if you look here, guys, here I turn the LED on, right? I want to keep the LED on for 1 second, right? So here I just to make it simple, I ignored some instruction. I didn't count some instructions. That's why if you ask for 1 second, it's not going to be 1 second. Okay, it's going to be more than 1 second because I ignored some instruction. For example, I ignored this one, right? I ignored this. I didn't count this one just to make it simple. Okay. Also, I ignored this jump. It's going to take some time. I ignored it, right? If you go to the subroutine, I ignored this push in the beginning. I ignored this poll at the end. Also, I ignored RTS. So actually, if you ask for 1 second, you are not going to get 1 second actually. But so you are telling us this is not useful? No, it is still useful. Why? Because if you need 1 second, and then what you get is 1.00000005. It's still 1 second. You got what I'm saying? Why? Because this instruction takes nothing. If you see what time it's going to take, 1, 2, 3, 4 instruction, nothing. You got what I'm saying? So what I'm saying, because 1 second is a long time. 1 second is long time. If I add 3, 4 instructions, they may take these 4 instructions. They may take just nanoseconds. Some nanoseconds. If you add nanosecond plus 1 second, nothing. But you understand what I'm saying? So if the delay is long, you're not going to have problem, right? But if you have a short delay, if your delay is short, if I want to make a delay 1 microsecond, 2 microsecond, now this start to have problems. You got what I'm saying? If the delay is short, because the part, this instruction now, the instruction I ignored, now they are going to have like big weight in case of short instruction. Anyway, but this, if you want to make a flashing, yeah, this should be good enough. But you have to understand, you have to keep in mind, and I think this will be a question in the coming lab, I guess. Okay, we have to keep in mind this is not very accurate, but it should be okay, because flashing, if it is 1 second and you make it 1.00005 seconds, okay, no one is gonna feel it, right? Anyway, any question? Okay, guys, any questions? Okay, look here. So, in this chapter and the coming chapters, guys, I'm gonna teach a number of subroutines like this one, like delay YMS. Okay, I'm gonna teach a number of subroutines, and then in exams, in quizzes, anything, you should. I'm gonna ask you. I'm gonna tell you just use the subroutine. Please don't write the content of the subroutine. I already know they are on the slide. So in the final exam, I'm not gonna ask you to copy whatever in the slide. Just I'm gonna tell you, just use the subroutine. Okay, guys? Okay, now, so we're gonna have a bunch. This is the beginning, this is the first one, but we're gonna have a number of subroutines. I'm gonna explain all of them, but you can just use them. Okay. Okay. That means if I want to use the subroutine, should I copy the subroutine and I put it in my code? Yes, you have to do that. Okay. So this is how your program should look like. So in your program, guys, as I said before, you have org here, 1000. If you remember, we called it, I think, ramstart. And in the file, ramstart is equal to 1000. Okay. And here you have to put your data. And then we have here another org, which is 4000 as we did before. And this 4000, we call it room start. In the code, you put room start. And room start is defined in the file as 4000. Okay. And then you put your code, your program here. And the way you have to put your code, as I explained last time, you have to put here the main program. And then you have to put here the subroutines. Okay, that's what I explained last time. This is how your program should look like. Okay, and in the very beginning here, if you have equate instruction, they have to be here. So the equate instructions, they have to be here. Okay, that's why in your program you include it. You remember when we included a file, every lab you include here. You include a file, okay, and this file should have equates. Okay, that's why we put the include here, because this is where you have to put equate. Equate have to be here. You understand what I'm saying? So every time in your program, you remember this file? Yeah, this file. Yeah, this is the file you include every time in your program. And I told you last time, if you look at the file, this file just have equates. Is that okay? So it has too many equates. As I said last time, DDRA, we're going to use it DTRA and port BTH, port PH, and so on. Okay. So we already include this file in your code. Okay. And you know, when you include, you actually, you know what happens when you include? It's like copy paste. So you copy the file, you put it here. And because this file already has weights, this is the right place. This is where I have to put weights. That's why I include the file here. Any question? Okay, guys, any question? So now let's return to my point. My point is that, so now you are telling us, starting chapter 3, 4, 5, we're going to have a bunch of subroutines, and most of the time we can just use the subroutines. And every time I want to use a subroutine, I have to copy it and have to paste it in my program. Okay. And sometimes it is a little bit complicated. Why it is complicated? Because sometimes one subroutine is going to put another 2 subroutines. So to put one subroutine, maybe you have to put another 2. Can I say? So I found a better idea. So a better idea, instead of you copy some subroutine, you put it in your program. I found a better idea. You know what the better idea I did? What I did, all the subroutines I'm going to teach in chapter 3, 4, 5, I put all of them in one file. Is that okay? And you can include this file, one file, include it, and that's it. You don't need to worry about anything. Is that what I'm saying? So what I did, I took all the subroutines I'm going to teach, I put them in one file, and then you can include it here. Okay, so what you have to do is, here in this part here you can write instruction like this one, you can include, and then this is the file I'm going to tell you now, the name of the file. You can include the file here. Is that okay? By including this file, actually you are going to put all the subroutines. Okay? So even if you don't use some of them, it's not going to hurt you. But just this is much easier than copy and paste. You just include it and that's it. And then you can use any subroutine I'm going to teach in chapter 3 to 5. Okay, guys, any question? So number 1, where is this file? Where is this file? How I include it? Okay. So let me tell you the conclusion. The conclusion is that part. Number 1, I'm going to teach many several subroutines in chapter 3, 4, 5. Instead of copy and paste, no, I have a better idea. Just include the file here, and then you can use many subroutines. Everything is really in the program. Okay. But still, you can put some subroutines as well. So you can here also, you can put some subroutines here, okay? Or after include, if your own subroutines. If you need some subroutine, you can add them. Okay. So number 1, where is this file? I'm going to tell you where is this file. I'm going to choose the file as well. So this is the programs. This is if you go to, this is the programs on the course website. If you go to assembly, for example, here under assembly you find a file. This file is called subroutines, as you see here. If I open this one, oops. If I open this file, yeah. So if you open this file, you find a bunch of subroutines I programmed. Okay, all the subroutines I'm gonna teach. Okay. So for example, let's look for delay YMS. Yeah, look here. This is delay YMS. Okay, delay YMS. Okay. Also, so this is the file here, guys. Okay. So number 2, how we include this file? Okay. You already know the name of the file, subroutines.inc. Okay. By the way, we made a mistake here. I think there is a typo in subroutines. I think U is missing. Anyway, you can change it if you want. That's okay. But if the spelling this way, if it is this way, so you have to write the same name in your file. Okay. So the TAIF, the T, it mistakes. U is missing. Okay, but that's okay. You can add the U, but or you can leave it without adding U's, but this same name you have to use in your file. So number 1, how in your program you are gonna include this file, okay, so that you can use it. I'm gonna tell you how. Okay. So if you go to lab 1, I'm going to go to lab 1 to show you what we did in lab 1, because almost we are going to do the same thing. So here in lab 1, you remember this one, guys? That's what you do in every lab. You say include, and then you say the name of this file, this one here, okay, this file, okay. We are going to do exactly same thing, but here you have to use the word subroutine. There is no U, okay, subroutine, you have to use the name of the file. One more thing, you should not put it here. You should not put it here, because this is the area for equate, okay? What you have to do, you have to put it here after this is your program, this is my program. So after you write your program, you have to write the include here, because this is a code. It has to be in the code area. So I have to write it here. Is that okay? So you have to do include exactly like this include. Okay, guys. Oops. So you have to do include like this one, but it has to be number one. You have to use the name of the file, subroutine.inc. Okay, that's number one. Number two, put it here, because this is a code, a program, subroutines. Once you do that, you should be happy. Why you should be happy? Because you already have the subroutine. You can use any subroutine application in the coming 3 chapter. You don't need to worry about copy paste. Is that okay? But still, you have 2 problems now. It's not gonna work this way. It's not gonna work. You have 2 problems. What are the 2 problems? Number one, the first problem. If you put it here and you run the code warrior is going to give you error. Warrior is going to tell you, where is this file? I'm not finding this file, right? Because this file is not coming to code warrior, right? So the code warrior is going to tell you, where is it? I don't know what is this file, right? So what you have to do is you have to include this file in your project, so the code warrior does not complain and tell you what is this file. How you should copy this file, and you have to put it in your project. How? Can you see this one here, guys? So you can see includes here. You have to make right click. You have here in includes. You have to make right click, and then you have to select add file. So here this one includes. So everything is included here. If you see this one, you can see all the files included in your project. So here, if you want to add one file here in the includes, right click and then select add file. And then once you select add file, locate the file in your hard disk, and then click OK so that you can edit. Is that okay? Once you see the file here, so it should be okay. So Google is not going to ask you what is the file. Okay, you have to make sure after you do that, the file is there. Is that okay? Guys, any question? So this is the first problem. The first problem, you have to include this file in your project so that you can use it. Okay? But someone can ask me, but we didn't do that before. We included this file. You remember this file here, this file we included it, but we didn't do that before. We didn't add the file. My answer is this file is coming with Code Warrior. So this file is already coming with Code Warrior. So it's already in your project. This is a default. Like in every project, this file is already there. That's why. But subroutines this is not coming with Code Warrior. I created it. That's why you have to edit. Okay. But the file we include every time, it's already there. That's why Code Warrior didn't complain. Okay. Is that okay, guys? Any question? Okay. So another thing, once you do that, this subroutine, I think you are going to receive error, because this is the last point. Because I think in one subroutine, we had to use counter. We had to use byte variable. It is called counter. Okay. That's why also in your program you have to define. You have to say counter dc.b. You can put any number. Is that okay? Just because we used it in one of the subroutines. So anyway, if you forget to do that, don't worry. Subroutine is gonna Code Warrior is gonna give you error. Code Warrior is gonna tell you in the subroutine you are using a variable called counter, but you don't define it. Okay? Maybe you are gonna be surprised, because in your program you don't use a variable called counter. So you didn't use counter. Any question, guys? So let me summarize what I said. What I said, guys, number one, we have a number of subroutines in assembly, okay? You can just use them, like the keypad, like when I teach the keypad here, we have a subroutine, we call it keypad, okay? I'm gonna explain how it works to learn how it works, but just you can just use it, okay? So this subroutine is already, and other subroutines, all of them, I put all of them in one file. You can include this file at the end of your program, okay? And then you can use all of them just to make it easy. And you don't need to copy and paste, just include that's it, okay? So this is, so what you have to do, number one, you have to write include instruction, that's number one. Number two, you have to add this file to your project, okay? Number three, you have to define a variable like the counter. Otherwise, code warrior is going to tell you you are using a variable called counter, but you don't define it. So, yeah. Any questions? Okay, guys. I think I also, because I think you are going to need this one in coming lab. I created another function. We call it delay y microsecond. Delay y microsecond. Okay. So you can find this one. Let me see if it's there or not. I think it's there, but let me check. No, y microsecond. Yeah, it's already there here. Okay. So this is the same idea. So this one is making a delay, but the amount of this delay is y microsecond. So if you look at this subroutine and this subroutine, they are exactly the same. The only difference is I'm not gonna repeat. I just deleted this instruction because this is microsecond. This part making microsecond. I'm gonna repeat this part y times. So I'm not. I just deleted the 1000 loop here. Okay. So this one is gonna make delay for y microsecond. Is that okay, guys? Any questions? It's the same idea. Okay. Now, that's what I told you last time. This is the signal you should see in the scope, and that's what we're gonna do in the coming lab. You're gonna do something like that. So you will see here it is 0 for 1 second. It's 1 for 1 second. 1 or 5 volt for sure. So 1 means 5 volt. So here, because the LED is off for 1 second, on for 1 second, and so should be like a square wave. Because actually what we are doing is a square wave. I'm generating a square wave. This flashing is actually square wave. And that's what I'm going to do in the coming lab. In the coming lab, I'm going to ask you to do different shapes of square waves. Very easy to do square waves. And then I'm going to ask you to see these square waves on the scope. Okay. Before I continue, I want to show you now the video. Okay. So in the very beginning here, guys, I'm gonna make one second and 1 second. So that's what I explained: 1,000 and 1,000, 1 second and 1 second, and then I'm gonna run it on the board. You will see the flashing. So it's gonna be here. You will see. If you see here, guys. So it's on for 1 second, off for 1 second, flashing. Okay. Now I'm gonna change. Now I'm gonna change it to half a second. So you will see now half a second. So you will see the flashing is faster. So I'm gonna make it like 500 now. So I'm gonna change this number here from 1,000 to 500. So you should see faster flashing. It's faster because half a second. You can make it quarter. Is that okay? It's faster, very easy, right? Now, I'm gonna make it 1 millisecond and 1 millisecond. Okay, what do you expect? What you are gonna see if I make it? Yes, I'm gonna see it like all the time, right? Because number one, the device itself cannot turn on and off that fast. You got what I'm saying? So you would see it stable all the time. Actually, it's on and off 1 millisecond, 1 millisecond. But what your eyes are gonna see is all the time. You see. Look here, I made it 1 for 1 millisecond. Also, I'm gonna make this one 1. Okay, so I want to tell you something. Number one, you have the board. Number two, you have all these programs. So when you go home, you can run these programs, you can play in these values, you can learn. That's my opinion. Number one, you have to learn these programs. Number two, you can move forward by changing these programs, but at least you can start with something. It's working. I'm sure they are working. We tested all these programs. Okay. So anyway, you will see how it is. So you can see here, guys, this one here, this one is very stable. Okay, so it's on all the time, very stable. For some reason, I don't know why. I don't know, maybe it's from the board, maybe whatever. This one came on. I don't know. I don't know why. This one turned it on. I don't know why. Okay, anyway. So don't look at this one. Look on this one, only this one. So I'm gonna hide this one. Yeah, look here, okay. Yeah, so this one you can see, yeah, look, it is on very stable, right? On all the time. Okay. Any question? Okay. So if I turn it on and off pretty fast, actually it's gonna look like it is on all the time. Is that okay? Any question? Okay. There is something I'm gonna explain later in details, but now I wanna give you some idea now because it's related to what happened now. It's related to the 1 millisecond how it is stable. Okay? We're gonna use this idea later. Okay, but I'm gonna explain it now because it's just related. Okay, what is this idea? I'm gonna tell you what is this idea. Okay, very interesting idea. I'm gonna tell you what is this quickly. Okay, look here, guys. I told you before we have port B, right? And I told you port B, we have LEDs are connected to port B, and we have BG1 to enable or disable the LEDs. Also, we have 7-segment display 1. So this is 7-segment display 1. We have display 2. We have display 3. We have display 4. So that's what you see here. So we have 4 displays. These 4 displays are connected to port B. And as I told you before, similar to BG1, everyone here has a pin for enable or disable. PB0, PB1, PB2, PB3. Is that okay? So if all of them are enabled, whatever I'm gonna write here has to be shown in all of them. Right? To be shown in all of them. So now the question is, that means if I write here the code for number 7 and I enable all the 7 segments, I have to see 7, 7, 7, 7, right? So I have to see here on the 7 segment because all of them are connected to the same port. So if I put number 7 on port B, if I enable all of them, you will see 7, 7, 7, 7. Doesn't make any sense, right? I don't want to use them this way. So they should not repeat. Okay? The way I have to use them is, if I want to display a number like this one, 3725, I want to see 3725. But the hardware is not helping me. Why? Because the way the hardware is connected is, whatever I put in port B has to be shown in all of them the same number. Because all of them are connected to port B. You understand, guys? So the question is that, using this hardware, using this design, how I can display a number like this one. 3725. How? I'm gonna tell you how. Okay, very interesting. Look here. Port P. I'm gonna put the code equivalent to 3 on port P. And then this display, I'm gonna turn this display on. So this display is gonna display 3. But the other displays, I'm gonna turn them off. So now, only one on at a time. So now you can see 3. Is that okay? After some time, I'm gonna put here in port B7. And in this time, I'm gonna turn this one on. So 7 should be shown here. Then after some time, I'm gonna put here in port B, I'm gonna put 2. And then now you can see, and this one is off, this one off. I'm gonna turn this one on so that you can see 2 here. Same thing here, 5. So I'm gonna turn this one off, I'm gonna turn this one off, I'm gonna turn this one off, and then I'm gonna put here 5. And then I'm gonna repeat, go back. I'm gonna repeat first. Okay, guys? Similar to the LED, when I turn the LED on and off very fast, it was very stable, right? It was on, very stable. Same thing here. If I do that very fast, you will see the number very stable. You will see it is like 3725. You are not going to see that one is on and the others are off. You are not going to see that. But you are going to see very stable number, 3725, if you do it very fast. Is that okay, guys? That's what we call time multiplexing. So this idea is called time multiplexing. Okay, guys? For sure, if I do it slowly, if it is slow, and when I teach it, I'm gonna shoot that video. I'm gonna make it slow, intentionally. I'm gonna make it slow. When it is slow, now you can see flicker. You can see this one is on, other is off. You can see this one is on, other. Now you can see flicker. But if I do fast, you will say it's very stable number. Similar to the LED. When I turn it on and go very fast, it was a very stable on, right? Any questions? But why? Why you complicate things this way? It's too complicated. Why we do that and we complicate it? Okay. It's interesting. It's important. Why? I'm going to tell you why. Because the other way, if you don't do time multiplexing, the other way is I'm going to use one LED, so I have to connect it to one port. And the another one, it has to be connected to another port. And this one connected to another port. And this one is connected to another port. So I have to use 4 ports. 4 ports. Here you can put the number. The number was 37. So here you can say 3725. Okay. So this is the other idea. So now, if you don't use time multiplexing, you have to use 4 different ports, right? And then you can put any number on each port this way. But for sure, that's not good. Why is that not good? Because we don't have too many ports. If I bring a microcontroller and I lose just 4 ports for the sitting segment, so I have other things to do, right? So what I want to tell you, what's interesting about this idea is, what's very interesting here, using only 1 port, how I can drive 4 different, or maybe it can be more than 4, okay, 4 or 5 different displays using only 1 port, because we don't have too many ports, okay? Because the other idea is this one, okay? Is that clear? Any question? I'm gonna give you more details later, but just I had to explain it now. Maybe it's a little bit early, but the reason I explain it now because it's somehow close. The concept here is somehow close to the LED. When I turn it on and off very fast, it was very stable on. Okay. Any questions? Okay. So now I am done with assembly. What I'm gonna do now, guys, I'm gonna explain how can we do the same program, this flashing LED. How can we do the same program using C language? Okay, that's what I'm gonna do now. Okay, but so for C language, guys, number 1, if you go to the course website, I know some of you may not like C language. Some of you may have bad experience in C language in in the course you took before, whatever. Some of you don't like it for some reason, but I wanna tell you something. The way you are gonna use C language is gonna be completely different from the way you used C language before. Here we focus on the hardware, right? So we're not gonna use, we're not gonna do object-oriented or something too complicated, right? Because now we are only programming hardware. Okay, so it's going to be much easier, much simpler than what you did before. Okay. Also, I did here some slides. Here, guys, you can see some slide. In this slide, I did a very quick revision on C language, just in case you need some help to remember C language. Okay. Unfortunately, I don't have time to explain these slides. Because I have important topics, honestly, in the course I need to cover. However, every time I teach one instruction in C language, I'm gonna explain it. Okay, this is similar to what I did in chapter 2. In chapter 2, I explained how while work is, how switch case works, and so on. Okay, same thing I'm gonna do here. Okay. So you have this slide, you can download, you can read it, and if you have any question, for sure you can ask us. But anyway. So here I'm gonna teach in C language. We have what we call bitwise operators. Bitwise, bit by bit operators. Okay, I'm gonna teach them now, bit by bit. How can you do bit by bit operators? Okay, the first logic operators. Okay, so here the first one here, guys, and this. So this one can do logic and bit by bit AND operation. This is the operator for AND. This is the operator for OR. This is the operator for XOR. This is the operator for NOT. This is the operator for shift right. This is the operator for shift left. I'm gonna give you an example now. Okay, guys. So here I'm teaching the operator in C language for bit by bit because we need them in order to do the special we need. Okay. So these are the operators. I'm going to give you examples. How can we use them? So I'm going to start with AND. So I'm going to give example for each one. So let's start with AND. So look what I did here, guys. I'm saying here port B. So port B is a byte. So port B is a byte. And then I'm going to do AND. So this operator is for AND bit by bit. And then here, this number is in hexadecimal, FE. So FE is actually 11111110. Okay. So before I move forward, I want to tell you something. Look here, guys. Here, similar to what we did in assembly, you have to use a prefix to tell me if this number is hexadecimal or binary and so on. That's exactly in C language. Same thing in C language. So if you use this prefix, can you see it here? This is similar to $sign in assembly, but here we use 0x. 0b is similar to percent in assembly, but here it's 0b. Okay. And if you put no, if there is no prefix, this is similar to assembly. That means it is decimal. Is that okay? It's pretty easy, right? Very easy. It's the same thing like assembly, but instead of using $sign, I'm going to use 0x. Instead of using percent, I'm going to use 0. Okay. So now, so that's why this one is 0x because it is hexadecimal. Okay, guys. So what this instruction is going to do? This is 1 byte, and this is 1 byte. Is going to do bit by bit logic AND, and then it's going to store the result in port B. So port B should equal port B and this value. So you know what this one is going to do? Okay, so here you are going to do AND operation. So this one is going to put 0 here, and then because it is 1, no change. It's going to come to here. And this result is going to go to port B. Okay, guys? Is that clear? Here. Okay. As I explained, okay, as I explained before in assembly, this is how we can clear some bits. Okay, so this instruction, I used AND operation to clear this bit. I cleared 1 bit. Is that okay? So let me tell you, nothing is new. This is exactly what I taught in assembly. In assembly, I told you to clear to clear some bits, you can use bit clear, or you can use logic AND. Is that okay? So here's that's exactly what I'm going to explain now. What I'm going to explain now for logic AND should help me to clear some bits. Okay, so you can use it in assembly as well, or in assembly you can use bit clear. In C, we don't have bit clear in C. In C, we don't have bit clear. If you want to clear some bits, you have to do logic AND. Okay. Also, as I said before, logic AND also can be used to check some bits. That's what I did in chapter 3. Logic ANDs can be used if you want to check some bits. Okay. This is also what we are going to do here in assembly. In C. I'm going to teach how can we use AND to check some bits. Okay. Logic OR, it's going to be used if you want to set bits. Yes. Okay. Or you can use bit set, but but we don't have bit set in C. So okay, so that's why you have to use OR. We can use XOR if you want to flip some bits. Is that okay, guys? I'm going to teach now how nothing is new. It's the same thing as I put it in assembly, but here I'm going to just use the connect. I'm going to use the connect of C, but logic as a concept is the same thing. So this is number one, guys. Very important. We are going to use it all the time. Very important. So you should learn in both, actually, in C or assembly. You should learn how can you clear some bit, how can you set some bit, how can you flip some bits, how can you check bits. All the time we are going to do it. Very important. Okay. So here in C, this is how we are going to do this. Okay. So port B should be for port B, and then you are going to clear one bit. Okay. So actually, when you clear one bit, here you actually turn the LED off, because this bit is connected to port B. So you can use this instruction to turn one LED off. Okay. Any question? Okay. And as you know, in C language, when I say y should equal y plus 2, it is the same thing to say y plus equal 2, right? That's what we do in C language. This is just short to format. Okay. Same thing here for this operator. Same thing. So if you write, so this one or this one, they are exactly same thing. Okay. Same thing. If you like to use this one all the time, it's okay. This one, you should understand this one and this one. Any question? Also here, now exactly same thing, but I'm going to use OR. As you see here, guys, I use OR. So what I do here, this is port B, and then I use 40. So 40 is 0, 0, 0, 0, 0, 0, 0, 1. This is 40, okay? So as you know from what I taught in chapter 2, see, this one should set, you set the last bit here. You set it, right? So because this one is gonna come here, and this you're gonna put 1 here. This is how can you set bit. That's what we did here, okay? So also you should, this instruction is used if you want to set 1 bit. I think I made a mistake, sorry. Yeah, so it should be 1, 0. Okay, so actually, yeah. So I'm gonna set this bit. Okay, this is not change. Okay, so here bit number 6. Okay, anyway, because it's 4. Okay, guys. Again, nothing is new. That's what I did in chapter 2. But here just I use the command. Okay, so very important to know, to learn this one, because this one is going to tell you how can you read some bits in C. This one is going to tell you, or you can learn from this one, how can you set some bits in C. Okay. Any questions? Same thing here. Nothing is new. This is how can you flip some bits. Is that okay? Because this is for XOR. This is how can you toggle or flip some bits, because this is 1. So actually, what I'm doing here, I flip this bit. You flip the first bit here. Okay. Any questions? Okay. So here again, you should learn how can you flip some bits, how can you set some bits, how can you clear some bits. Okay. Also, I'm going to teach how can you check some bits. Okay. Check bits. Okay. But before I explain how can you check some bits, so here I want to explain this one. this operator. I told you this operator is called complement. So this operator should do the once complement. Is that okay? So let's see how it works. Look how it works here. BTH is port H. BTH is port H. And as I told you before, port H is connected to the switch. Okay. So here I'm gonna say port B. Don't forget, port B is the LEDs. Okay. So if I say, let me do it without this one. I'm gonna delete this one. Okay. So I'm gonna say port B equal BTH. You know what this means? So I say port B equal BTH. You know what this means? It means I'm gonna read port H, which is switches. I'm gonna copy it here. That's what it is. Is that okay? So I'm gonna copy from here to here. So I'm gonna equal the switches here. Okay. How it works? I'm gonna tell you how it works. It works this way. I'm gonna give you more details later, but this is how it works, guys. This is PTH. PTH. If this bit is zero, that means the switch is closed. So if you connect the switch, it's gonna give you zero. Okay. I'm gonna tell you how later. This is how the hardware circuit is gonna do. The hardware circuit, when I open the switch, you're gonna put 0 volt. This is how the hardware circuit is. And if I get here 1, that means the switch is open. Okay. So 1 means open. If you open the switch, the hardware circuit is gonna put 5 volt on the pin, and then you can get 1 volt. Is that okay? So if I take this one and I send it to port B, what's gonna happen? What's gonna happen if the LED is off? It means the switch is closed. And if the LED is on, that means the switch is open. Is that true? Because this one is gonna put 5 volt here. Okay. So I'm gonna read one port, I'm gonna send it to the other port. Is that okay, guys? So if I say port B equal BTH, so this will be the logic. So the logic is, if I see at any time when I connect the switch, the corresponding LED is going to be off, right? If I open the switch, the corresponding LED is going to be on, right? You feel like the logic here is not true. It should be. What if I want the other logic? What do you mean by the other logic? The other logic is if the switch is connected, the LED is to be on, right? This is okay. So what I have to do after I reach these values, I have to complement. So after I reach this value, I have to complement these values before I send them to here. Complement them. If you complement them, that means if the switch is closed, okay, which is 0, I'm gonna make it 1, so that you can turn the LED on. And that's exactly what I did when I said port B equal complement of PTH. So this one means complement. So you're gonna read PTH, you're gonna complement the bits, and you're gonna send the result to port B. To have a different logic. The logic now is if the switch is closed, I'm gonna read 0, this 0 is gonna be 1, I'm gonna turn the LED on. So if the LED is on, means the switch is closed. LED is off, the switch is open. Okay, anyway, you understand what is the difference between this one and this one? Okay, so this one you are gonna read one port, input port, you're gonna put it in output port. This one I'm gonna read one port, okay, and then I'm gonna complement the value, and then I'm gonna write it. Okay? Now I'm gonna explain 2 more operators. This operator here and this operator here. This operator are shift. Okay, this is similar to the shift instruction I taught in assembly. Okay, but there is a small difference. What is the small difference? Look here, guys. What's gonna happen here? This is port B. I'm gonna shift to the right. So this is right shift. But this number here is gonna tell you how many shifts you wanna do. We didn't have this option in assembly. So here that means port B. I'm gonna shift it to the right 3 times. Shift 3 times, and then I'm gonna put the result in. Right? We didn't have this option in assembly. In assembly, if you want to shift 3 times, you have to write the instruction 3 times. But okay. Same thing here. So you are gonna read the value of port B. The value of port B, you are gonna shift it to the left 4 times, and then I'm gonna store the result in port B. Again, you can use this compact format if you like it. Any questions? Okay. Look here, guys. Here I'm going to teach another operators. You should be familiar with these operators. With these operators, we call it relational or logical operators. Okay. I think I explained some of these operators before. Okay. These operators are used to make conditions. So this used to make conditions. So this one means equal, not equal, greater, greater or equal, less or equal, and this one is and this one is or, and this one is not. Okay. What may confuse you is this one is completely different from this one. Writing, they look the same, but they are completely different. Okay. This is and bit by bit, and bit by bit. But this one for condition. So here I'm going to say if A greater than 2, this is a condition, and B less than 5. So here, in order to execute the body of if, we have 2 conditions. The 2 conditions should be true. So this is and. But this is not bit by bit and. This is bit by bit and. Is that you got what I'm saying? Same thing for this one. This one for condition, this is or for condition. But if you use only one, so this is bit by bit or. Any question? Okay, I'm going to give you examples on these operators. This is very easy. So for example here, this is basics. If A1 is equal to A2, so we're going to execute the body if A1 is equal to A2, right? And as you know from C language, if the body of if is only one instruction, you don't need to use braces, right? You don't need to use braces. But if you have more than one instruction, so if the body of if is more than one instruction, you have to use braces. Okay? Or you can use braces all the time. It's not going to hurt you. You can use braces all the time. Okay? Let's see another one here. If A1 does not equal E2, so this means this one means does not equal. Okay? If A1 does not equal E2, so I'm going to execute the body of if it is not equal. Okay? If A1 is greater than E2, we're going to execute the body of if A1 is greater than E2. Greater or equal, less or equal. Is that okay? That's easy, right? And now, that's what I explained right now, guys. Now, sometimes I have complex condition, as I said before. So now this is one condition, and this is another condition. I think I explained something like that in chapter 2. So here, I'm going to execute the body of if the 2 conditions are true. This one is true, and this one is true. Again, you should understand big difference between this one and this operator and this operator. Okay, you should understand big difference. Okay, here, this one here. Okay, so just we're very close to finish the lecture. I know it's so I'm not going to take more time. Just I want to finish this part. So here's the same thing here for OR, guys. So here we have 2 conditions. I'm going to execute the body of if or this is OR relation. If this condition is true or this condition is true. Okay. Any question? This one is not. This one is not. In order to execute the body of if, the condition here has to be false. So the condition, because if this condition is false, this operator is going to make it true. Okay, it's going to make it true. So it has here, in order to execute the body of, maybe it's very rare to do it this way, but you should understand what this means. Okay, so here I'm going to execute the body of if I does not equal 2, the condition here is false. So instead of writing this way, maybe sometimes it's maybe rare to write this way, okay? Or I can say if I does not equal 2. Maybe that's easier, but anyway. Any questions? Okay, so let me tell you the conclusion now, guys. The conclusion is, this is the most important part, guys. I explained similar to assembly. I explained how can you do bitwise AND, how can you do bitwise OR, how can you do bitwise XOR. I explained how can you use AND to clear some bits. as shown here. Okay. Also, I explained how can we use AND in order to set some bits. I explained how can we use XOR in order to flip some bits. What I'm going to explain now is similar to what I did in chapter 2. How can we use AND to check some bits? Okay, so idea is that if I want to check some bits, as I told you, for example, this is PTH. So in PTH, this is the switches here. I need to know if the switch is connected or not. I need to know if the switch is connected or not. Because if the switch is connected, I'm going to do something. If it's not connected, I'm going to do something else. You got what I'm saying? So for example, if the switch is connected, run flashing. If the switch is off, flashing is off. If the switch is connected, run the buzzer. Okay, depends on what you want to do. But based on the value of the switch, I have to do something. Okay, so I need to check. How can you check? As I explained in chapter 2, you can use AND. Okay, so the way I'm gonna do it here. So here I can put 1 here, guys, and then I'm gonna put 0, 0, 0, 0, 0, 0, 0. Okay, and then I'm gonna do AND operation. And as I said in chapter 2, so this one here, P node, I'm gonna get P node, and then I'm gonna get 0, 0, 0, 0, 0. Okay, by this way, I'm gonna check this switch. I'm gonna check this switch. And now the result should be, if the result is 0, that means B node is 0. Now, if the result is 1, that means B node equal to 1. Does that make sense, right? So you have to do AND operation and then look at the value of the result. What is the value of this part? If the value is 0, that means the only way to get 0 is 0. Otherwise, 1. We're gonna do the same thing to check some bits here in C language. Is that okay? So the way I'm gonna do it is, so let me explain it here, because there is some tricky point here you should learn. So the tricky point you should learn is, look here, guys. So I'm gonna say PTH, right, and 0x 01. Okay, if PTH and 01, okay, equal to 0x 01, right? So that means if the first switch is connected, if the first switch is 1, so 1 here means disconnected, or you can say 0 if you want. So here what I want to say, as you know, here I'm gonna check the first bit. If the first bit is 1, okay, 1 means it's disconnected, right? So if you can make it 0, you can make it 0, and in this way, I'm gonna execute the body. So here, execute this one. If bit 0 equals 0, and bit 0 is equal to 0, as I'm gonna explain later, that means the switch is connected. Okay, so else you can do here. So I'm gonna come to here if the switch is open. So here I'm gonna check. Here I'm gonna check the first bit. Okay, and then if the switch is connected, I'm gonna execute this operation. If the switch is disconnected, I'm gonna execute this. But there is a tricky point here. Okay, what is the tricky point? I'm gonna tell you what is the tricky point. Okay, you know, in C language, when we do any operation, when we do computation, there is some priority, right? So for example, multiplication has to be done first, right? And then after that, addition, there is some priority. We follow a certain priority. For some reason, I don't know why, the people who created the C language, okay, they give more priority to equal. So they give this equal more priority than this one. Okay, let me tell you what you want to do and what the C language is going to do. What I want to do is, I want to do this competition first, and then I want to check. This is number 2. That's what I want to do. Is that right? But this is not what the C language is going to do. What the C language is going to do, this language, because this operation has more priority. They did this way. Okay, so they are going to do this one first, and then if the result is true, it's going to be 1. Otherwise, it is 0, and then it's going to do AND operation. So this would be second. Anyway, that's not what I want to do. Anyway, to solve this problem, you have to use parentheses. Okay. So we have to put it this way so that we have to finish this part first and then check this. Is that clear? Okay, guys. Anyway, I'm almost done. So now, just a few minutes. Okay, I'm done. Nothing new I'm gonna teach. So now, how can, in flashing LED, how can we do this in C language? Okay, so if you look at the pseudocode, this pseudocode is similar exactly similar to the assembly. What I did in the assembly in the first part here. In the first part here, you have to do configuration in the first part, and then you have to pull PB0 high. You have to wait 1 second. You have to pull it low, and then you have to wait 1 second and keep repeating. Okay, so I need to do configuration. So how can we do configuration? Believe me, I'm gonna do exactly the same thing as I did before here, exactly same thing, but I'm gonna use the format of C language instead of the assembly instructions here, okay? So here, as you see here, for example, here, so this is direction register B. I'm gonna configure direction register B as output. I'm gonna configure register G as output. I'm gonna configure register B as output, as you see here. And then I'm gonna put 0 in J to enable LED. I'm gonna put FF in P to disable LEDs. Okay. In the very beginning, always we are gonna write this instruction. Okay. So this is the file we include all the time. Okay. Even in C. Okay. This instruction here has to tell. This instruction has to tell the code warrior what is the family. This is the family of our microcontroller. Okay. Also, we are gonna include this file here. You know, in C language, if you want to use, like for example, in math, if you want to use some mathematical function, you have to include the math library. Okay, so this is the main one, but still you can include, if you need, you can include other libraries here. Okay, and then this is the code. This is the program here. You can see here. This is how I created infinite loop, and I explained in chapter. I explained in chapter 2 how can it be this way. Why one? This one, what this one means? This one means a condition that's always true. Okay, because if you have a condition here, for example, a greater than 2, this is going to be the C is going to solve this one and going to replace it by 1 or 0. If it is 1, it's going to be 1. If it's true, it's 1. False, it's going to be 0. So if I say 1, it means like you have a condition that's true all the time. Okay. Anyway, just 1 minute, and then you are going to take 10 minutes break. Okay. So anyway, so quickly here. So here we have a function. This function LED on. So this function should turn one LED on, and you have to tell me which LED. So here I put number 0. So if here I should put a number from 0 to 7. So you have to tell me which LED you want to turn on. Here I want to turn LED number 0. That's why I put 0 here. Okay. And then we have a function here to wait 1 second. It's called millisecond delay. And here I have to put 1000. Same thing here. We have LED off. Okay. So this function should turn LED off. So this one here I'm gonna put number 0 because I want to turn LED number 0 on. Here I want to turn LED number 0 off, and then I can repeat. Anyway, I'm gonna repeat. I'm gonna continue next time from now. So let's start 7.5.